The Automated Podcast.
Welcome again to Automated. This is the podcast looking at the impact of technology on jobs. I'm the host, Mark Verbenkov. So in the last episode, we looked at industrial robots, and one of the things that I came across during this past week actually relates to Foxconn and industrial robots still. So I wanted to talk about this briefly and then jump into service robots. So Foxconn, some of you might have heard of. This is the Chinese iPhone manufacturer, and they're actually quite infamous for having a number of suicide nets for their low-paid workers. And in 2011, they said that they would have about 1 million industrial robots in their facilities within the next 3 years, yet they seem to have only implemented about 40,000. And I wanted to look at why this was, as it was very relevant for the last episode. So they still have about 1 million workers. And the CEO gave this reason for why they only implemented some 40,000 industrial robots and not the million that they wanted. So the CEO says this: the life cycle of consumer products like smartphones has become shorter and shorter. So it's not cost effective to spend money on a fully automated production line, as humans are more flexible and cost effective at a big number of workstations. So this is something that's also been tried by many other manufacturers, such as Fiat, Volkswagen, GM, and even most recently Tesla, and they have all failed at doing this. So Tesla was also planning to build a fully automated factory for its Model 3, but came into a number of troubles due to the complexity of automating the final assembly of the vehicle. And this is where the car is put together. So according to Tesla, automation simply can't deal with the complexity, inconsistencies, variation, and other things that just simply go wrong that humans can. In final assembly, robots can apply torque consistently, but they really don't detect and account for threads that aren't straight, bolts that don't quite fit, fasteners that don't align, or seals that have a defect. However, humans are really good at this. So humans are able to spot things that aren't right, stop the process, and try to get them fixed. And it would appear that full automation, though desirable by many of these companies, is still a ways away. But let's go back to service robots as the topic of today. So service robots are broken into two groups, professional and domestic, and both have quite a varied amount of robots in both of the groups. So if we look at the professional ones first, these include robots such as AGVs, or autonomous guided vehicles, drones, exoskeletons, and both defense and medical robots. While the personal or domestic robots include technologies such as the robotic vacuum cleaner, lawnmower, and pool cleaning robot. And these personal or domestic robots also include entertainment robots such as toys, hobby systems, and even education and research robots are lumped into this. But we're really only going to look at the main robots today in this episode, as there's just too many to take into consideration for one specific episode. But just to give kind of a overall view for the amount of service robots out there, in 2018, there were around 275,000 professional service robots that were sold. And this is up from the 170,000 that were sold in 2017. While for the domestic robots, it was about 16 million, which predominantly came from the robot vacuums. And it's expected that both groups will continue to grow as the years go on. So as I mentioned, there's really too many technologies to look at in one specific episode. So what we'll be doing is looking at the general look of a number of these technologies and how they specifically affect jobs. However, if you feel that this is too much of a superficial episode and really want another episode that targets one or two of these robots in particular, please let me know either through Twitter or LinkedIn, and I'll make sure to do so if there's enough interest. So we can start with autonomous guided vehicles, or AGVs, and these are robots that typically follow floor sensors or wires placed on the ground and use that for navigation. They generally consist of a base where products can be placed onto them and have four wheels or tracks to move with. They're really mostly used in logistics and manufacturing, but they're slowly starting to creep more and more into last mile delivery. They're used in many different applications, such as moving pallets, being loaded with shipping containers, delivering raw materials in automotive factories, but mostly are really used within warehouses to move products around. So much like industrial robots versus cobots, as I talked about in the last episode, there is now a second generation of AGVs that have really only emerged over the last few years. These are called the Autonomous Mobile Robot, or AMR. And these use radio waves, vision cameras, magnets, or lasers for navigation. And much like the cobot, they are more flexible, intelligent, as well as cost-effective, and there's no need for an expensive wire system to guide them, as the navigation system is built in. Yet today, the term AGV is really used for both, and because of these newer navigational systems, the AGVs are moving more and more into hospitals where they can connect to and both use elevators and doors, and they do this in order to deliver bedding, meals, as well as use food trays and other things that are used in the hospitals. So AGVs actually make up 41% of all service robots sold, and this was the main reason that I wanted to focus on this one technology first. And the most well-known AGV example, I think, is that of the Kiva systems being bought out by Amazon in 2012 for the new warehouses that they were building. And this actually sparked the whole AGV industry boom that has been experienced over the last 8 years or so. So perhaps you've seen one of the videos of the small orange robots moving around and lifting and moving Amazon bins. But if you haven't, that's okay. I'll put a link in the show notes for a very short video. So utilizing AGVs can have a lot of augmenting effects for human workers, as the AGV can be paired with a human and actually take up a lot of the products that are being moved around, reducing a lot of the physical limitations as well as possible injuries for human workers. However, some interesting things can happen when they are applied in large groups, and this is done especially in warehouses. So lights out factories or dark warehouses exist where there is no need for light, heating, or any cooling, as humans don't need to be constantly on the working floor. So AGVs can scan as well as navigate in absolute darkness. And this enables tremendous savings for a company, enabling them to expand and grow and obviously potentially hire more people, but for different sorts of tasks. However, it is excessively expensive to set one of these dark warehouses up, and most attempts have only really gone to about 80%, where most of the warehouse doesn't have human activity, but some parts still do. So we can shift our focus now onto the next tech, which is looking at drones, which really fit into a number of different sectors, or they're applied to a number of different sectors, such as inspection and maintenance, last mile delivery, soon potentially personal transportation, but we'll talk about this more in the next episode, as well as defense. But only 5% of service robots sold back in 2018 were actually for defense. And I'm going to have a future episode dedicated to automation in the military entirely, so we won't really look at this here today. But if we look at inspection and maintenance, especially within agriculture, though AGVs are actually used for things like weed control or spraying, even seeding, and there are some robot arms that are used for picking, drones are really highly utilized within agriculture. So by using drones, you can actually get a very good picture of the state of an entire crop field, especially as many of these fields can be several hundred acres in size, which make it absolutely impossible to see the middle or many certain parts of it without using drones. And the reason that this is very important is that you can pinpoint specific places that need to be harvested, sprayed, or taken care of, increasing the efficiency of the farmers working on the fields. So this feeds into the idea of precision farming, which uses real-time data to make decisions, as well as maximize efficiencies and ultimately the yields that the farmers are trying to get. However, this will not replace farmers at all. It is purely augmenting their capabilities and really improves their decision making in the work that they're doing now. However, when drones are used for inspection and maintenance in infrastructure, this can actually lead to reducing a number of injuries as well as decreasing risks for people. So a really great example of this are the robots that have been used in the Fukushima reactor cleanup. And though they're not aerial drones, the purpose of this is the same when looking underwater. So back in March of 2011, if you may remember, there was an earthquake off the coast of Japan that hit 9.0 on the Richter scale, and a subsequent tsunami also hit the island and caused the Fukushima reactor to melt down 3 of the 6 total reactors. So it actually wasn't until July of 2017 that the melted nuclear fuel was first located. And this was done by a shoebox-sized remote robot called Little Sunfish. And it was built to withstand high degrees of radiation and also have a long enough battery life to be able to make multiple trips, as many of its predecessors had gone in and died due to the significant amounts of radiation there. So this is evidently a use case for augmenting human personnel rather than automating. But you can completely see how using robots in very hazardous situations is a much better idea than using humans. So we can shift our focus now to delivery, specifically last mile delivery, where drones have a really high potential to radically transform the sector as well as the jobs within it. So labor is really the biggest cost for last mile delivery today. And I've also heard that for the growing food and restaurant delivery industry, most, if not all, of the major delivery companies out there are not even profitable due to these high labor costs, but as well as, of course, the high perishability of the food being transported. However, as I mentioned, this is only something that I've heard. If you know for sure, please let me know. So in order to deal with these high labor costs, the idea of using drones for the last mile delivery has been put forward over and over the last several years. And there is now a pilot project in Iceland with an Israeli company called Skytrex that will have drones deliver various goods in people's backyards. So it already has coverage of about half the city, and if fully implemented, there will be no need for last mile delivery to be carried out by any bike or scooter anymore. And this has actually been a growing job since the beginning of online delivery took off only a few years ago. However, what is perhaps even more interesting is the social benefit of drone use in the disadvantaged parts of the world, where there's actually very little access to both road or rail. And because of this, many emergency and healthcare needs aren't met. But drone use can actually change this. So Zipline is actually one of the world's largest drone delivery networks, and it delivers vaccines, medicine, and blood, as well as a number of other things, within Ghana to over 2,500 health facilities, and these actually reach over 20 million people. So this is really impressive, and it's actually only one of many examples out there. But I think it's really easy to see that it can generate an entirely new delivery industry to support the bottom billion, while both improving the quality of life for millions and creating local as well as international employment opportunities. So we can move on to the next technology, which is exoskeletons. And these are either powered or passive suits that are worn, and they actually act as augmenters to the wearer for various tasks. So I actually went to a conference last year where a number of them were showcased and was able to try on a passive exoskeleton that used a number of springs and pulleys to support my arms. So it was actually really easy to hold my arms out either in front of me or reach up, and had minimal effort to do so. So of course this is very useful for people that have to work in manufacturing and other sectors where they have to look up or constantly be holding things above their head throughout the day. So exoskeletons are really simply a form of supporting employees, but doesn't really have any automation impact, apart from allowing an individual to perform tasks for longer periods of time without being worn out or needing a second person to help them with lifting something at their job. So if we turn our attention now towards the medical or healthcare industry and refer back to the last episode's discussion, specifically focusing on the both precision as well as the repeatability capabilities of robotic systems, we can see that a surgeon's tiring or even shaking hand is really quite a risk during a long operation, especially as compared to the stable movement of a robot. So this is why surgical robots have predominantly changed surgeries over the course of the last decades and really allow minimal invasiveness during surgeries and really allows patients to recover faster. So some examples of the use of surgical robots are to cut out cancerous tissue, especially near difficult places such as blood vessels, nerves, or organs. They're also used for supporting kidney removal as well as coronary artery bypasses. So needless to say, this is also a growing industry. However, only 5,000 surgical robots were sold last year. So that's it for kind of the professional service robots. We can now look at the domestic ones. And the first one that we're going to be looking at are the robot vacuums, which actually make up something like 90% of all domestic robots being sold. So I actually bought one of these robotic vacuums this year, so I can have a bit of a personal perspective on it. So my robot actually goes and bumps into the walls in order to find the edges of the apartment and works from there to clean the rest of the floor. But it actually kept bumping into my feet as well as chair while I was preparing for this episode earlier today. But I can't really complain, as its main impact is really similar to that of the dishwashers of the 1970s, as I can only imagine. So instead of cleaning my floors, I'm actually able to spend more time on this podcast or be with friends or do other things that are way more interesting than sweeping floors. So personally, I'm really looking forward to seeing how different aspects of housework can be automated in the future, as well as using or implementing a number of the technologies that can do so. So I've seen a couple technologies that already piqued my interest. One of them is called Molly, and this is a set of robotic arms that can actually cook your meals for you. There's also something called Foldimate, which is undergoing a crowdfunding program right now, and it's practically a laundry folder. So it will fold all of your clothes as well as towels and other things that you need. But unfortunately, these things aren't commercially ready yet. But I'll keep you posted if I come across new ones, or if you know of any similar techs that are available right now, please let me know. So the last technology that I wanted to look at within this category are robot lawnmowers. So they're pretty self-explanatory. However, I actually saw my first one about 4 years ago while I was writing my master's thesis in Oslo. And as I was writing my thesis on the adoption of robots in different organizations within Norway, I thought that I could interview the ground staff and actually try to incorporate what they're saying into my thesis. Unfortunately, this didn't work, so I'm really happy to be able to share a little bit of what I learned back then. So the 10 or so staff people that I was able to interview were actually really happy to have had the robotic lawnmower adopted, as they didn't need to spend time or waste time cutting the grass or the lawn anymore. It actually freed them up to be able to do a number of the different tasks that they couldn't get to otherwise, and that were maybe a little bit more challenging or more enjoyable for them. So nobody was fired because these lawnmowers were taken on. There wasn't a dedicated lawn staff employee. But then again, on the other hand, no extra people needed to be hired. So as you can tell, there are so many robots that fit within these service categories, and it's really impossible to get to all of them. But I wanted to very briefly talk about a few that didn't really fit into the previous sections. So the first set of robots belongs to Boston Dynamics, and Boston Dynamics is very famous, if not the most famous robotic developer on the planet, as they have had really multiple videos of their robots that have gone viral, and they've gotten, I think, several million views for a couple of them. I'll post some of them in the show notes for you. So the Atlas robot is probably the most famous one, and this is a humanoid robot that can do a number of different advanced acrobatic feats. Although it's mostly used for publicity, it's still not commercially available. However, another one of their robots, Spot, which kind of resembles a dog, actually only this past week has been made available to buy, and its main function is to do inspection in closed and control spaces. And finally, the last kind of honorable mention are elder care robots. So specifically, there's one called Robear from a Japanese company, and it can lift patients from a bed without any human help. So this really frees up the healthcare staff in hospitals that are using it, and this really prevents a number of injuries. So to conclude, we can see that service robots are exceptionally varied in both type and application, yet it's really AGVs, or autonomous guided vehicles, that are the bulk of commercial adoption, while their smaller home vacuum counterpart really dominate the domestic market. So depending on which technology you look at and really the way in which it is applied, the potential for job automation or change is predominant among these types of automation technologies. But really both autonomous guided vehicles as well as drones in particular have a much greater capability to automate specific jobs if utilized at scale. So that's it for robots. Next week, we'll be looking at autonomous vehicles. So thanks for listening. And as always, if you have liked the podcast and want to support it, please leave a review or rating on iTunes or wherever you listen to your podcast.
The Automated Podcast.